I hope everyone can hear us now. Madhukar, if you don't mind, just
Sure.
give me a quick recap.
All right. So hopefully everybody can hear us now. And if you missed what I was just covering is real-time or real-time retrieval augmented generation. This is where you take your data, the fresh data, and then you pass it on to your large language model. And the second thing was around multimodal RAG, which is where, again, Gemini really shines when it comes to audio, video, as well as even images. So we're going to show use of Gemini Ultra today and also multimodal RAG. But typically what happens is if you want to provide a rich context, your unstructured data is sitting somewhere else. So if you employ, let's say, a vector-only database, then you just store a small amount of metadata with it. You do some sort of a search with it, a semantic search, get the metadata, and then you go out and then retrieve the actual data. Today, we'll show how all of that data could be sitting in one place. So you can do different kinds of searches, lexical, semantic. You can do analytics, and you can do sort by, filter by, and re-ranking in one single query. And then the last piece, which is again which is close to what we do, is RAG with analytics. So let's say you are responding to a user about a certain thing. When you also respond with analytics, for example, oh, so many people have asked these questions, or this is the likelihood of it having a positive feedback and things like that, then you can use it both for the admin side, but also for providing a richer context to your LLM as well. So in terms of when it comes to really building something that is specific to you and specific to your industry, there are three things that have evolved in the last few days, last few months, I would say. The first thing is fine-tuning models, and this is where Vertex AI really shines, and we'll talk a little bit more about it. But what's the difference between fine-tuning as well as retrieval augmented generation? So retrieval augmented generation is you are in real time providing the context to the large language model. So if I have 10 petabytes of data, I go do a search, match it against the query, and bring it. But if I want the large language model to behave in a certain way, that's where fine-tuning comes in. So typically what you can do in Vertex AI is you can choose a tunable model and give it a data set. And that data set could be sitting in a Google bucket. And that data set is a bunch of queries and responses. So again, if this was, let's say, a financial services LLM-based application, I wanted to follow the regulations. I wanted to follow certain rules. I wanted to be extra conservative when it comes to accuracy, so I can fine-tune that. And typically, like I said, in Vertex AI, it's very easy to do, which is what we have done here. You can even take an embedding model, you can fine-tune it with your own vocabulary, and then you can run it inside of Vertex AI at an API endpoint that you can consume. So there are two ways to do this. One is, of course, you take a fine-tunable model that's already in Vertex AI, and then you provide your data set and you get your new version. Or you can take your existing embedding model, you fine-tune it, and then you upload it to Vertex AI and host it where you can then start to consume it. The second thing I would say that has become a lot more common now is you want to have certain production level quality of retrieval augmented generation or RAG. One, you want to score and evaluate your RAG responses. So for example, if I asked a question from my RAG pipeline and it gave me ranked by 4 or 5 responses, I want to score it and then keep a record of that to make sure that later on somebody gets to audit it and come back and retrain it or fine-tune it more in order to make sure it gets more and more accurate over time. Second is context mining. So when, a few months ago, when everybody was doing retrieval augmented generation, it was pretty naive retrieval augmented generation. You take a PDF, you chunk it, convert it into embeddings, and you do a dot product, get back the data, and you're done. But now it's also about, okay, but I have massive amounts of data. So can I create a knowledge graph where I have specific entities and the relationships to each other? And in a typical relational database, there's just like a lookup table where you have the different entities, you have the relationships, and then you have the connectors associated with them. So now you can also get richer data with knowledge graph using SingleStore. The other thing I would say is that you want the freshness of data. Typically, what happens in a vector-only database is you take data, you convert it into an embedding, but it's not available for immediate SQL queries because it goes and does indexing, it propagates to all the nodes and so on. With SingleStore, because it's a memory first, and we use something called pipelines, the data comes in, hits the memory, we do a fast commit. So it's immediately available for query while the index is being built out, depending on your use case. And the last thing I would say is also guardrails. So guardrails is, it started off as something where you don't want your application to respond to certain questions, especially in financial services. You don't want to respond to question when somebody says something confidential or something harmful. So guardrail is a way, it's almost like a advanced semantic cache where it sees the response, matches it with what it already has, and says, no, this one I am not going to even send it to my RAG pipeline. I'm going to say no to it. So guardrail, think of it as a router that sits between your application, your LLM, and your vector database, which allows you to prevent certain harmful behavior. But what it also does is it is also used for efficiency, because if the same thing has been asked 500 times, guardrail knows that, okay, this is something that I've had a massive hit in. So just like a cache, it just takes the cache and responds back from in memory. The other things that have really started to come about is, of course, explainability, especially in health or financial services. When you get a response, the regulators might ask, explain how you got to this. Tell me what is the audit capabilities for it. So LangChain has this new product called LangSmith. This is a paid product, by the way, and we are not sponsoring it, but I personally used it. I love it. And it shows you that explainability. So if you look at the screenshot over here, every time you ask a question, even with your RAG pipeline, it gives you a full trace, and it's in real time, so you can go back and also look at it. But what it also does, it's retrain or fine tune your model on the fly. So if somebody asks a question and you get a thumbs up or a thumbs down, that goes back into the future responses. So it knows that, okay, this one is actually something that somebody said is the right response. And then the other thing I would say is we talked about the knowledge graphs, but it is also now about structured and unstructured data, right? Initially it was about, okay, let's just do a semantic search. And in semantic search, you have primarily two different kinds of method. You either do a cosine similarity or you do a Euclidean distance. But now you also have structured data, which could be just sitting in plain SQL or semi-structured like JSON. And then we talked about the data freshness. So what I wanted to do next is, before we invite Dr. Ali here from Google, I wanted to give you a little bit of introduction of what is SingleStore. So SingleStore, if you haven't heard of it, it's a data platform which combines both transactions as well as analytical workloads in one single use case, and it does it across petabyte scale in a few milliseconds. So it is used for modern applications like rideshare, where you have millions of rows of data and you're trying to do group by, sum, average, and you want to do it in a few milliseconds because you offer personalized recommendation to your users. It's also used for in-app analytics apps. So if you're using something like Strava or Oura Ring or Whoop, where it's a lot about real-time analytics that you want to show to the user or even to your admin, then that's the second place. And of course, the third one is Gen AI application. So give you a little bit of history. We started off actually in 2011, so we are not a new startup. We were known as MemSQL, and it was one of the in-memory database along with Redis and Memcache. Redis and Memcache is now used most for caching as well as session management. But we built a 3-tier architecture that we patented that takes your data from in-memory to your local disk, SSDs and NVMEs, and then finally to object storage. And as the data moves along, we keep a copy of the row-based also as a columnar data, which means as soon as the data hits SingleStore, you're able to run analytics similar to what you would do in Snowflake, for example, but at a massive scale. In 2017, when Google wrote the paper, Attention is All You Need, which introduced the seminal concept of transformer models, we had a few customers request vector search and vector data type support inside of SingleStore. So we have had that since 2017, and we have several customers, even before the GPTs came out, that have been using us in production for semantic search across live streaming videos as well as data and so on. So if I were to say that there are 3 things that is differentiated about SingleStore, it's the speed, scale, and simplicity. Speed, because we talked about how it's across both structured and unstructured kind of data. And we do both semantic, which is the vector searches, but we also do lexical, which is exact keyword match. And it's under the hood, it uses Lucene. We do both transactional workload as well as analytical workload. So you could do, again, group by, sum, average, all of that across 100 million rows, and it still gives it to you in a few milliseconds. And we support all data types, including JSON, including, of course, the Mongo APIs as well, except for graph. But you can build knowledge graphs inside of SingleStore too. These are some of the key capabilities. If you're interested in finding more, I encourage you to go to singlestore.com and then get more. And for those who are in the room, I'm happy to chat more. Rohit is here as well, so we can definitely talk more about it. All right. So what I want to do next was just show this reference architecture, and Rohit is going to show a demo as well on what is advanced RAG. If you remember, and we do weekly webinars, by the way, on Gen AI and mostly around RAG, but this is I would say, an advanced version of naive RAG, where you first see the user ask the question, and typically that could be in a SingleStore notebook, or this could be in your application. And let's say you gave it a screenshot. It's a customer support part. So we make a call to Gemini Vision. We get back some more additional data about it. Then we decompose that information. We send it to SingleStore after getting the vectors for it. And then SingleStore responds, and you get back that data. But behind the scenes, to keep the information or the knowledge base fresh, we have a Kafka stream that is taking all your real-time data, and it's creating embeddings on the fly. And that's when it uses the fine-tuned model from Google Vertex AI, and then puts it back into SingleStore. If you want it, you can even keep it in a very large table. So this gives you the ability to then take any industry and using Vertex AI, fine-tune your model, and you bring in your real-time data, if that's what you choose to do. And your application could, in this case, is notebook, but could be your front-end application, or it could be your agent-oriented application as well. Now, we talked about vectors. When we started off in 2017, it was primarily exact KNN search. So it was more fine-tuned towards accuracy. Now, in January of this year, we also added a few other indexes or indices for vectors, these being PQ, IVF, and HNSW. PQ is product quantization, IVF is inverted index, HNSW is hierarchical navigable small word. PQ and IVF is primarily more tuned towards approximate nearest search, and so is HNSW. But one of the things that SingleStore does is whenever data comes in, we compress it by 65 to 70%, which is why it's far more efficient in running in memory. And then as it moves along, your storage footprint is also a lot lower. We also introduced something called vector data type. So there is strict typing and making sure that as a developer, you're not accidentally introducing errors. Prior to the vector data type that we introduced, you could just store it as a blob, and you can store it as a binary. And then we introduced a CDC in from MySQL, MongoDB, and of course, with Kafka as well. And we have connectors directly with LangChain, Llama Index, also OpenAI. And we also have SDKs as well as APIs, so you can do CRUD as with RBAC at row level data. So now I would like to invite Dr. Ali so he can talk about Vertex AI and how and what he's seeing in the Gen AI world. You want to use your computer?
So I think, yeah, I think we might want to unshare the screen.
Yep. Unshare here.
Okay, very good. Hopefully people can hear me. Excellent. Hi, everyone. Madhukar, thank you for the excellent presentation and introduction so far. So one of the things that we're seeing a lot of is that different companies who are implementing generative AI are at different stages of maturity. And it's super important for us to be able to understand where we are so that we can determine where we want to go. Like a GPS, right? You want to go somewhere. If you don't know where you are, the GPS can't take you anywhere. So we need to determine exactly where we are from an architectural perspective. Do we want to just select and prompt and be done with it? Or as Madhukar was mentioning, do we want to do retrieval augmentation? So that's a new level of maturity. A lot of people are focusing on prompting, that's great. The next level of maturity is all of the discussion that Madhukar just did with the capabilities that SingleStore, for example, provides for retrieval augmented generation. And so, thank you. They just gave me the power. I feel the power. The next level of capability and sophistication in your journey for generative AI is to be able to actually take the jargon, the lexicon, the domain-specific knowledge you have, let's say in finance. You want to add that to your foundation model. The foundation model has general, think of the foundation model as knowing Wikipedia. I mean, that's an oversimplification. But if you think of it that way, you can add specialization to the model by fine-tuning the model. That fine-tuning occurs when you give it financial information of your company. It's not going to be leaked anywhere, it's just for you. or retail information, etc. And then you may want to say, okay, as Monica was saying, when you get a result, you want to make sure it actually is accurate, or the accuracy discussion that you're having. And you sometimes need to have real-time access to the accuracy of that information. So a search becomes super important. Search in different databases, search out there in the internet, search from different locations where you have your source, ground truth. And then ultimately you need to evaluate whether that source that was brought to you is valid or not. Is it a citation that is correct or not? And so at another level of maturity, you want to have everything reproducible, and you would want to have a pipeline of capabilities. So this is a quiz, because it flashes, you see it for 1 second, and then it's gone. So did you remember it? So it's like we are conditioning you. This is actually a human fine-tune. I'm kidding. This is just a joke. So LLM Ops is about using machine learning DevOps, ML Ops, plus with the generative AI world, you need to evaluate your RAG, you need to evaluate your model, your prompting, the outcome of your model, the drift that you have when you actually generate a response from inference. So that evaluation, that pipeline, which allows you to retrain the observability that monitors the drift of what you expected from what you actually got, that's all of machine learning, right? You get a result, you know what you expected, you decrease the loss function through backpropagation or some other mechanism. Today, it's really mostly backpropagation. So perfect timing. And then the next level of maturity is where level 6, you're actually going into multi-agent systems. So you have different, just as you're all experts in slightly different areas, each one of you, each one of us in this room has a focus. Some of it overlaps, but maybe you're in financial services and you're an expert in retail and you're an expert in tuning models and you're an expert in data science per se, you're an expert in data mining. So with these different expertise in that, using that same analogy, you want to have a routing sent to the specific model who can get the job done very well. And then retrieve that information back like a workflow. You're orchestrating that between different agents, which are maybe smaller large language models, and then retrieving that path so that you can combine the inputs of everyone. You're calling your friends, do this, do that. You're combining them together, and now here's an output for the user that makes sense. So with that, these are the levels of maturity that we're generally seeing. And so if you want to achieve a RAG level, as Madhukar was saying, that's a great starting point. And then if you want to achieve more, you'll know, okay, I need some other components that I need to implement. That's where the solution completeness of, and it's a partnership that we have with SingleStore, is so great, because you can have the best of what SingleStore offers, let's say in terms of real-time retrieval augmentation with high accuracy, being able to invoke it using a SQL-like query for a dot product, for a vector search, doing that semantic search. But then as you evolve your platform, you can leverage this partnership, because you can leverage the Google set of components that will help you in future phases of your journey. That's going to be very critical, because you're not stuck with just one level of capability. You're actually able to evolve as your application evolves, as the industry evolves, as your customer expectations evolve. You can do more and more on the Google Cloud Platform because you have them all available. You don't have to use them all at the same time. But what you can do is you can use what you need at that point in time. So with that, we now know that we have these levels of maturity. And as we go through these levels of maturity, we have the ability to continue. I will continue, yes. This is another flash quiz. Okay, you have 2 seconds to view it, and then it's gone. So this reference architecture shows you all of the soup to nuts, everything you need. This when we talk about solution completeness in those levels of maturity. we're talking about implementing each of these components as you need them. For example, in our case for today, we're doing prompting, we're doing retrieval augmentation, and we're doing serving. And the database is a SingleStore vector database. So it's super important to understand that there is this backdrop of the reference architecture and that you can evolve along with it as you mature. You have more of these components light up, so to speak, and you can leverage each one of them because you now have the platforms behind it to leverage them. It's important to also understand that everybody talks about models these days. It's sort of like when you want to buy a car. If you want to buy a car, is the only thing you ask the car dealership about the engine? Probably not. You ask about a whole lot of other things. Is it comfortable to drive? What's the steering wheel? Is it electric? Is it not? Whatever your, So the idea is models are super important. And in the case of Google, we have the best models in the industry. Well, best is relative to the week, right? Everybody's going to be slightly better next week, and then we're going to catch up. So it's a constant race. So today, state-of-the-art models you can find on leaderboards, and it's like the stock market. They keep going up and down. But at Google, we're constantly evolving our models, and we have research and our cloud in the actual same company, which really helps if you have it in the same company because you actually are able to incorporate research immediately into a platform that everybody can use. So with that, this is kind of the backdrop of our Vertex AI platform, which is our flagship overall platform for generative AI and predictive AI, leveraging our database, data warehouse, data manipulation capabilities as well, and having that highly integrated. So with that,
yeah, we'll show a
yes,
demo, sort of.
exactly. Wonderful. I'm going to have our colleague from SingleStore now come up and
Just mute yourself.
yes, I will mute myself on Zoom.
as benign or malicious, just using Gemini. So there are a couple of reasons why you should use SingleStore and GCP in this case. First of all, you can deploy your machine learning models on Vertex AI, like Ali just mentioned. The second is with SingleStore, you get streaming ingest, as Madhukar mentioned. So all of your data is coming in real time. Now, in order to hit those SLAs of single-digit millisecond response times, we are utilizing indexed ANN search in SingleStore. In this case, I've built an HNSW PQ index. And finally, of course, we have built an agentic application using Gemini. So let me go ahead and show you the architecture, if my screen responds. All right, here we go. So network traffic, like I mentioned before, we are streaming that into a machine learning model, getting the embedding vectors, and we're putting the embedding vectors and the network traffic logs into a Kafka topic. We're hooking up our SingleStore pipeline to that Kafka topic and streaming the data directly into our database. All right. Now, on the other end, we have our end user who's going to be asking questions. Our Gemini Ultra is going to turn that question into a SQL query and execute it against the SingleStore database. Then the query results are going to be returned to the user in a natural language format. All right, that makes sense to everyone?
Can you go back to the
Yeah, for sure.
talk about the agentic AI applications with Gemini?
Yeah. So there are two different, we like to classify AI applications into two different types. The first is information retrieval, where essentially you just, enter a question and your LLM will just retrieve the information from the database, right? So you retrieve the information from the database, your LLM provides you a natural language response. In this case, we have an agentic AI application, which is going to essentially take a command, convert it into a SQL query, and then execute that. So it's doing something for you. It's not just retrieving the information, but the LLM is doing something for you. Does that make sense?
I had a basic question, please.
Yeah.
So, if on the next slide, please. So,
Yeah.
it seems to me, Gemini Ultra is just using SingleStore as a backend data store.
Yeah.
But Gemini probably has other backends, right? So,
Yeah. So the reason why we're using SingleStore in this case is, yeah.
If you repeat the question.
Oh, yeah. Sorry. So the question was essentially why, like, we're using SingleStore as a backend in this case, but Gemini can use other databases as a backend. So the reason why we're using SingleStore in this case is, first of all, we're getting streaming ingest from SingleStore pipelines. So all of the data of the network traffic is coming in directly. It's immediately queryable as it comes into the database. The second point is, alongside that streaming ingest, we're also getting the capability of indexed ANN search to label our traffic events as benign or malicious in real time. So we're getting that single millisecond response time on those queries with those labels. Does that make sense?
it does, but again, hypothetically, can we use DynamoDB here or some other Google offering, say Spanner?
Perhaps. I'm not entirely sure about that.
The uniqueness aspects is that you're getting the Kafka topic in real time ingested into SingleStore through the SingleStore pipeline. That's a uniqueness of SingleStore. Right? So that's one of the better together aspects of SingleStore and Google AI together.
Just to repeat what Ali said, essentially we are using SingleStore pipelines to bring the data directly into SingleStore from our Kafka topic. So this integration is the unique differentiator. That's why we have that better together story. Does that make sense?
Yes.
Awesome.
Thanks.
Yeah.
So I'm not familiar with the architecture of SingleStore. Is it a SQL? Is it a NoSQL?
Yeah.
Is it a graph database? Is it a vector like what?
So SingleStore is a modern data platform, we like to say, but you can query your SingleStore database with standard SQL syntax. We have support for many different data types, from geospatial data, JSON data, relational data, to vector data as well. So you can think of SingleStore as like a relational database, essentially.
Very quick
Yeah.
question here. So I saw the user on the top right up there. I think that's the user for querying the SingleStore.
Yeah.
Who's the data provider in this case? I do not have enough context on my topic.
I see. So we're providing the data to SingleStore. So the question was, who is providing the data to the SingleStore database? So we're providing the data to SingleStore from the Kafka topic. Does that make sense?
Yeah, who's subscribing to Kafka? Who's sending the data?
Oh, so we have a bunch of network traffic logs stored as a CSV file. We're essentially just pulling rows from that and putting them into the Kafka topic. Does that make sense?
Okay, so in this case, if it's like this is the AI threat detection etc.
Yeah.
So the information provided to Kafka topic is the threat base information.
Yes.
Yeah, so just to confirm, the Kafka topic is being subscribed by the single store pipeline.
That makes
But the
sense?
network traffic is being piped into some location and then pulled into the Kafka topic that's subscribed to that location.
Okay.
Yeah.
Sounds good. Thank
Yeah, so just to recap, the network traffic is being pulled into a location first before being put into the Kafka topic. And then we pipeline that into SingleStore. All right. Any questions?
These are great questions, but
Yeah. I really like these.
these people are engaged.
All right, so with that in mind, let me go ahead and show you the demo. So I'm going to scroll over to this one. So you can see on the left-hand side of the screen, we have the network events, which are being streamed into our SingleStore database. And you can see we're doing something on the order of 7 to 8 events per second. Now, what we're doing is within SingleStore, we have a repository of about 1 million vectors with the labels of benign or malicious. We're doing Euclidean distance to check whether, what are the closest vectors to the incoming embedding vectors. And that's how we're going to be labeling these new incoming events. Does that make sense to everyone? Okay, so let's go ahead and ask some questions. And I forgot to put this in the question samples, but the first question I want to ask is describe the database. So let's go ahead and see what we get. So right now the question is going to Gemini. Gemini is going to execute that against our database and return a response. Okay, so you can see that the database contains 2 tables, model results, which is our repository table. I'm just telling you that out of the box. And this other table, which is where the streaming events are going in. It's also going to describe the query used to get that response. So with that in mind, I've left this running for a little bit of time, so we're going to have quite a few events, but let's go ahead and ask how many events were logged in this table. So we're just going to wait for the response. And you can see there are 417,000 events logged in this table, and it just used the count star function. All right, so let's I'm going to skip over this question, but let's go ahead and ask, what is the count of the latest streaming events that are labeled as malicious? This is fairly important for us to know. And it's going to describe how it got that result as well. We're just going to wait for a response. There we go. So we can see that the count of the latest streaming connections, which can be labeled as malicious, is 3. And it describes a fairly complicated SQL query that it used to query against this database, return the results for malicious events. But at the end of the day, what we're doing is we're essentially comparing these using the Euclidean distance operator over here, right? And then we're doing a bunch of other things alongside that. We're doing some group bys, we're doing some order bys, limits, all of that within one SQL query. Okay? Yeah.
Is the citation on your where the information coming from that is getting logged as part of the response that you are generating?
What do you mean by citation?
So what is the source, right?
Yeah, so the question was essentially, what is the source of this data? So we have taken the data from essentially the people who developed this machine learning model. They've trained it on a bunch of network traffic data from a couple of days from whatever their source was. I can provide you guys the citation for that data afterwards if that's what you want.
But you don't store any citation information in the database message.
So when you say citation
For
information,
example, so there are many AI chatbots, right?
Mhm.
So when you ask any question, right?
Mhm.
For example, with data. So when you ask a question, you get the summary and you get the citation list and then the text.
I see.
Summary.
I see.
Right?
Yeah,
So
no,
I was
so
just trying to compare,
Yeah.
how is it different than
right. So we're actually not storing like the citations right now. That's something that you can build into the system. This is a very basic kind of demo, which doesn't include that information. But when it comes to the source of the information, as in like how are we labeling these events as benign or malicious, essentially you can imagine that the citation equivalent of that is the model results table. So what we're doing is we're comparing the distance of the incoming embedding vector to the vectors that exist in the model results table. And we're basically just saying, okay, what are the top 5 results, right? For the closest vectors. And then we're saying, okay, whichever one has like benign as the top 5 results, we're going to label it as benign. Whichever ones are malicious, we're going to label as malicious. Does that make sense? So that's the equivalent, right? It's in a classical chatbot case, whatever the closest chunk of text is to the query text is going to be returned as your relevant result. So the citation would reference whatever document that chunk of text was a part of, right? So you would just have to add a little bit of extra information. Does that make sense? Awesome.
There's one question from the
Sure.
virtual audience. How does Gemini know about the Euclidean distance function?
That's a very good question. I have provided a comprehensive list of SingleStore's vector functions as context to Gemini as part of my prompt. So it essentially knows how, like, the Euclidean distance function, it knows the shape of some of the queries that I've run against the database before. It has a memory table as well, which actually I dropped before this. But essentially, you can imagine that I've provided a lot of these queries and query shapes as context as part of my prompt. So if I provide new prompts to this, it'll be able to create things along the lines of these queries. So actually, to show you a little bit about that, I can ask this chatbot a prompt, basically, which is going to design a query very similar to this one, but it's not exactly the same. So the question that I have over here is, how do we go about labeling events as benign or malicious? So let me go ahead and ask that question. We're going to get some results in a minute. But essentially, I've provided as context to the chatbot all of that information. So you can see, right, just scrolling back to the top, it describes the SQL query that it used. It also described the list of events, the latest events, and the decided labels as malicious or benign. And you can see it's a very similar function, but instead of doing a select count star, it's just done a select star from the last one. So, a very similar prompt, a very similar query was used as part of my prompt. So it kind of knows how to design these queries, right? So like I mentioned before, if you implement like a memory table and do semantic search over the previously asked questions, that is another way you can provide this sort of query as context. Does that make sense? Yeah.
So this query looks very long. Is there a way for it to explain to me so I can verify that it is actually doing what it's supposed to be doing, so I understand it's correct?
Yeah. So I've included over here a query explanation as part of my prompt. So you can see it first calculates the Euclidean distance between the model results and the model results blob. So the model results are from the table. The blob is the new network event that's come in. So it calculates the Euclidean distance, and then there's a bunch of other filters going on in order to decide that label, right? So this is the explanation of the query.
You can also just copy paste this query into SingleStore, and you can see the verified results.
Yeah. So by the way, to Madhukar's point, copying the query directly into SingleStore, you're going to get this table that you see over here. This is going to be the results table that you get from SingleStore. Yeah.
So the benign and malicious labels, is this something that we would expect to be brought in at some point before we actually get to the query to Gemini? Basically,
Yeah.
The model that decides benign or malicious, and then
You can, right? So the original model, of course, the goal was not to output embedding vectors. The goal was to decide whether it's benign or malicious. What I did was I removed that last classifier network layer and essentially just extracted the output as the vector. But if you wanted to ingest it directly into SingleStore, then you could do that. Your label would just be another column. But for the purposes of showcasing the vector capabilities, we have the output now as an embedding vector, and we're doing these calculations of Euclidean distance on the fly.
Any online questions?
No.
Awesome. Okay, so
Actually, one just came in. How
Yeah.
do you find the malicious event?
That's a good question. So it's basically through this SQL query that I'm showing over here. Essentially, what we do is we're labeling them based on Euclidean distance to the nearest neighbors, right? So whichever vectors are closest, in the model results table, those are the ones that have their labels already as benign or malicious. So those ones, whatever the closest vectors are, we're essentially just labeling our new vector with that information. Of course, there's a little bit more information, like a little bit more complications going on, but that's the essence of it.
One thing I wanted to point out is that this is a really good example of how predictive AI traditional database and vector stores and generative AI, all four of them work together to derive business value. That combination, I think, is important because so for example, Ultra is generating SQL, is being prompted to generate SQL. It's being asked to predict the label based on an initial vector embedding that was given to it. So all of these are different aspects that are brought together in this. This is seemingly a very simple example, but actually it's pretty complex. So great job.
Oh, thank you. Thank you. Yeah, just to recap that point, when it comes to, some of the key capabilities here, Gemini Ultra is converting a question, a natural language question, into a SQL query, right? It is executing that query against a SingleStore database. And within SingleStore, we are storing all of our network data alongside with the embedding vectors. We have a timestamp column as well. So we're storing, time series data. And we're alongside our vector search, we can do a bunch of these filters. And Gemini is capable of understanding how to build those queries. And it's able to interpret the results of those queries as well. So it's providing a natural language response back to the user. Yeah.
Okay, so if you go back to your example.
This one?
Yeah, inside this example, the question that you asked doesn't necessarily ask for a table, right?
No.
But the answer you got back was a table.
Yes.
I remember inside of a previous slide that we had a handful of different prompting tools like eSpy and other things to be able to handle these types of outcomes.
Mm-hmm.
So is it the case that outside of SingleStore, but inside of your interactions with Gemini, you would be able to make this work a little bit better? Is it extremely necessary for it to make a SQL query every time? Is there something hard coded here?
Yeah. So essentially the shape of the query has been provided as context.
Okay.
So all of these different questions, right? So all of the questions like what is the count of the latest streaming connections? What is the latest events that can be labeled as malicious? How did we label them as benign or malicious? That example has been provided to Gemini because those are the types of questions I know are going to be asked, right? So, when you have that sort of information, you can hard code that. That's entirely within your purview. If you don't have information, right, that's where that whole fine-tuning of models comes in that Madhukar was mentioning, right? You can provide essentially feedback to your model. This is not what I wanted. This is not the query that I wanted. So let me hard code that new query as an example, right? Or I'll put it in another table where I'm going to search through previously asked questions. I'm going to search through example questions where I know what the query is. I'm going to execute that query, or I'm going to modify that query to the specifics of the question. Right.
And then you do a few shots to be able to get it.
Exactly.
Yeah, so let me jump in here.
Yeah, go
because
for it.
I know we have 4 minutes, so I'll wrap it up here. I think it's picking up from here. So imagine this, if there was no Gen AI, nothing else. If you wanted to do this, you have to first train your network data and build your own machine learning model. Then you would take that data and label it as the data is coming in. And then what you would do is once the data is in, there's some sort of a time lag before you look at it. But in a use case like this, a few seconds matter because if you're running your query, even after a few seconds, that malicious query or whatever it is has already done damage. So what's different over here is we take as Ali was saying, take a combination of the ML model, but you can run ad hoc queries using SingleStore and Gen AI, and you're doing it in literally a few seconds. So what it allows you to do is to take any kind of data, take any kind of machine learning model that either you have trained or you've taken, or an embedding model or a combination thereof, stream that data into SingleStore, and then you start querying it in real time, which gives you, all the capabilities that we're talking about. But the thing to note here is that it's also running analytics in addition to classification. Typically, if you're using some other database or data platform, you would have vectors in one place, you would have the transactional in another place, and then you would have analytics in a columnar database. And all of that takes latency and moving around data, which is the cost. So that's the key takeaway over here. Make sense? Yeah.
Can you also provide explanation of why it was tagged as malicious?
Can you provide explanation of why it was tagged malicious? So the machine learning model that Rohit took is trained against a certain set of data set. of what is deemed as malicious and what is benign. We take the same machine learning model, and as the data is coming in, we use that to then label it. So now it's in a table and it has been labeled as benign or malicious. So specifically, what is a malicious query? That could be defined within the machine learning model, either based on your data or industry data, right? And there are certain parameters and vectors around that.
Can you provide a pattern correlation of those data points that you used to?
Yeah, so a couple of, I'm not a security expert, but I can say changing IP addresses of the same user ID that is coming in, or you certainly see a surge of queries coming in from the exact same user ID, or anything that has a DDoS kind of a fingerprint to it. There are a bunch of these that you could just basically use to train your ML model.
Right, but can you provide that explanation of things?
Oh, I see. So within SingleStore, can you provide that? Yeah. So think of it as, SingleStore is like a very large relational, but also columnar database. You can store that in any table. So you're asking for explainability. It could say, this is the reason why we think it's malicious. Here's the fingerprint for it, right? You can do that too.
So just to add on to that, Madhukar, essentially you can give Gemini, you can give Gemini like the task, like, hey, I want you to analyze the malicious events, right? So it'll design a SQL query that basically selects out all of the malicious events from this table and tries to find a pattern from it. It returns that entire set of malicious events to Gemini as context. And then it says, okay, what's the pattern here? Let me try and find it, right? So that's kind of another way that this can happen.
Thank you.
So is there a way to incorporate, like, what is the confidence level of the SQL query generated? Because ultimately it's a chatbot that's generating. And every time, like, if it is a frequently asked thing and we have the higher confidence level, so a person might not need to check it again.
Yeah, so the question is there a way to define the confidence level of the SQL generated and also the response? The answer is yes, you can score it. And a couple of different ways to do it. And also whether you want to store it, if it's a thumbs up and all that. But the way you do that is within vector functions as well, there's dot product. The dot product also gives you the ranking associated with it. So you can get the response sorted by the ranking, just use the top one, or you can use an exact KNN, which gives you an exact match of what you already have in the database. But usually re-ranking and sorting, those are some of the ways you could use to make sure that it's giving you the right answer. Do we have one?
We do. So someone had two questions. First question, is the producer to Kafka topic the user who is asking the questions? And then following that, where do you see this being in real life applications? For example, one thing I can think of is probably prompt-based data access for the user, but mostly for data audit.
Yeah, Rohit, do you want to take that?
Yeah. So just to go back to the architecture diagram, the producer for the Kafka topic, I can give you a little bit more of an idea of the setup for how this data is getting into SingleStore. Essentially, it's a random data, not generator, but we have a CSV file from the test data for the machine learning model. And essentially, we're just pulling like one row every 20 milliseconds, running it through the machine learning model and pushing that to a Kafka topic.
Yeah, so and going back to the other part of the question, and where do you see the use cases? I would say the use cases is really around when you have real-time data, you need data freshness, you need analytics along with vectors, and you want to provide that rich context to the large language model. So yes, ad hoc query gives you one of those use cases, but there could be a bunch of others too that you could do, especially in financial services.
One more, I think then we can rip it out. Let's say we wanted to add a risk score on a scale of 100. Would there be something we have to do in Vertex, or can SingleStore provide that as part of the SQL query? How would you approach designing for this requirement?
So the question is, if you want to add a risk factor to every single incident that is coming in, where would you define it? I would say it really depends on your implementation. It could be part of your machine learning model, which gives you that classification, but as a score, or you could use the user feedback As they come in, you store that in a table, then you use that to retrain or fine tune. Or the third one could be yeah, I think those are the two I can think of right now, but I'm sure there are other implementation details there too. Was Juan going to show the notebook example, or are we done?
Ali, do we want to hand it over to Juan?
Either me or Juan, we were gonna tag team and show him the notebooks.
All right, so we'll be seeing a notebook example as well from Ali. We keep this.
Thank you, thank you. Okay, very good. And can I have the power as well? Okay, excellent. So I am going to call. I've unmuted. So I am Alina today here on Zoom. So I'm going to call on my colleague Juan Bustos, all the way from the East Coast, to talk about our ingestion pipeline, and I will be the scroller. Juan, take it away, please.
Thank you so much, Dr. Ali. Hello, everyone. I'm from the future. Can you hear me?
Yes.
Yes. Amazing. Thank you so much. Thank you for this presentation. It has been like great, and thank you so much for our hosts from SingleStore for having us. Essentially, we're going to walk through one example where we are going to work on a RAG pipeline leveraging Vertex AI and SingleStore. This is composed by two notebooks. The first one will download a dataset. It will generate embeddings and ingest it on a SingleStore database. And the second notebook will leverage Vertex AI models to answer some questions. Actually, we have a surprise on which models we're going to use. The first step here, as you see, will be to authenticate yourself to get access to the platform. We're going to import some models, and you see that here we are importing the text embedding model. So this is a Vertex AI model called embeddings for text, which essentially will generate embeddings from a chunk of text. Also for this demo, we're going to use LangChain, but not in a traditional way. You know, LangChain is a framework that allows you to build end-to-end applications. But in this case, we're going to use LangChain only for the document chunking. We will define the location, we will define a project, the S2 location, and then we're going to obtain the data set. This data set is composed by documents from our most favorite data set available, which is the IRS tax code. We know that everybody's very excited about tax season coming, and we cannot stop paying our taxes. So why not talking about our taxes? As you can see, we will download the data set, and we will ingest a series of files that include text files, PDF with images, and we're going to leverage LangChain's capability for working on this. Once we download the data set, then we will process them. For example, for the case of the PDFs, we will use the unstructured library that will extract the text from the PDF, especially if it has images, and then we're going to chunk these documents. By chunking, we mean we will just limit the size of the documents, and then we will set up the chunk overlap. This is one of the knobs that you will see if you're building your own applications, and there's no one size fits all. So the beauty of these notebooks is that it allows you to experiment what are the optimal settings for your application. Finally, in the second step, we're going to leverage LangChain library for Vertex AI embeddings. And with 4 lines of code, we will process the documents and ingest them into our SingleStore database. And that's the ingestion portion. After this step is done, you will have in your SingleStore database all the tax data you need to have a fantastic fun time. Any questions about this process?
Python
Is there only a Python SDK?
For Vertex AI? I'm sorry, I cannot hear the room.
The question is, what languages do we support for the Vertex APIs? Is it only Python?
Oh, thank you so much for that question. No, it's not only Python. We also have Go, Java, and Node.js, but also you have the ability to call the API endpoints via curl. So essentially, you can leverage any HTTP library that you have in your choice of language to use it.
Brilliant. Thank you so much.
Thank you. So back to you,
So
Ali. I will
I'm
stay
going
here
to
for questions.
thank Juan, and I'm going to jump. Why do you keep muting me? I'm kidding. It's because I talk too much. Might as well have Juan do this. So basically here, we have so this is the SingleStore location. We're going to actually use a combination of models. One of the models we're going to use is what's in production, which is Gemini Pro 1.0, which is GA, has been GA for. Note the threshold. This comes in when you're doing what? This is a quiz. Classification. Wrong. Sorry. I'm sorry.
How accurate the answer is?
How accurate the answer is? Come on, people. You're data scientists, machine learning. What is a threshold for vector store and embeddings? Similarity, cosine similarity, right? And what kind of product? Dot product. Thank you. The gentleman here, Paul, he gets the prize. So the threshold says whenever, you don't mind me kidding with you, is it okay? Yeah, sorry. So whenever you do a vector product, when you do a dot product of a vector with another vector, you want to see how close these are. And if it's within 70% closeness, you consider to be close enough. Is this a reality? We don't know. We just experiment. Juan was talking about the chunking. You have overlaps of 50. We did 200, size chunks. Who knows if that's good? We have to experiment to see for the topology of that data set, does this chunking, overlap, and threshold actually work? So
The recommended temperature here.
what is the recommended temperature? For RAG, the recommended temperature is Kelvin, 0. So there's no hallucination. Yes, thank you. Thank you for
I
that.
saw it's 0.1, that's why.
0.1 because you're dipping your toes in the water but not quite getting into the pool because it's too cold, right? We trust our models. So I mean, you don't have to put it as 0, and it will only retrieve what you need. So here, this is Juan's ask question implementation of the vector similarity search. This is where the threshold gets filtered here. And if the threshold is below, it's going to punt. It's going to say, sorry, I don't know. I'm not even going to answer your question. Thank you very much. So the embeddings in the vector similarity search for SingleStore has the content itself, which is the actual text that was chunked that Juan was talking about earlier. It's the actual embedding that is stored as a vector and the metadata information about the chunk, where the citation you were talking about earlier, which page, etc. What's the document name, and so on. And then this is a very nice prompt that Juan has written. So you're an intelligent assistant. He's trying to talk up the model so the model feels good about itself. You're an intelligent assistant helping users with their question, but please only answer the piece of information that answer the question. And we're using what kind of a paradigm here, people? Is another quiz. Chain of thought. Thank you. The gentleman here. Rohit. Fantastic. Chain of thought. Think step by step. You can use a variation of that as well. Just explain yourself step by step or explain the rationale for something. These models consider those to be similar. Effectively, what you're doing here is here's the predicting the custom trained model. And here's your API endpoint. You're providing it with a JSON format of the parsed dictionary. Here's the endpoint. You have the text embedding, the Gecko text embedding query. And here's the actual query. You're essentially saying, perform the dot product, consider the content and the metadata, perform the dot product, and then here, you take the query embeddings that are given to you, and then score it. And then the score will be returned as a score, and you're going to determine what the fidelity is of that filter. So the filter threshold is going to be assessed here, and then you're going to filter unique documents. You're going to obtain the context. This method or function is going to obtain the context. This is where the actual processing for the large language model occurs. We at Google like to always put these harm categories there, so you set it definitively. If you want to block things, if you want to allow a little bit more permissive, depending on your application, you set it here. And then you put the max number of tokens, the temperature that you were suggesting, top P, top K, and then essentially ask it. So we have two methods here. One is we're going to actually look at Gemini Pro, but we're also going to look at little Gemma. Gemma is our 2 billion, in this case, 7 billion parameter model that is the open model. And we're going to be asking the question, hitting the endpoint. And all of this essentially culminates with two templates. We have a template for Gemma, and we have the LLM query, which we're providing it with the context, the question, and the answer. So if you query your W2 form, you're getting from Gemini Pro and Gemma 7B. What is this IT business? Who knows what the IT is?
Instructions.
Thank you. Thank you. Instructions. So we have two versions. We have a pre-trained only, and then we have an instruction tuned version, which is specifically utilized for chat capabilities. So the responses are coming back, and the responses, are indicating what the W2 form is. This is the response from Gemini Pro 1.0. This is 7B. So anytime a little kid does something impressive, we applaud it. So 7B, Gemma is doing pretty well here. We applaud Gemma. It's no, Gemini Pro is it's a hefty model, so it better know what it's doing, and it does. So when Gemma does it, we're very happy. Now, this is the answers coming only from the model itself without the context provided in the RAG. And this is the information coming from the RAG. Juan, do you want to comment on this? It's your code.
Absolutely, and thank you for that. So the intent here is to show the value from RAG. It's not only about doing mitigating the hallucinations, but also is conditioning the model outputs. As you can see in the model's context, without RAG, you will have like the general knowledge that the model may have about a topic. As you know, tax information is very popular. So of course, the models have that in the corpora that they were trained on. Hence the reason why they have plausible answers that are accurate about them. But if you see here in the context for RAG, there's a very specific language and the answers are formulated from it. We have a set of questions. There's one question in particular that I would like to highlight. I think it's number 4. So I will let Ali go through all those questions until we get to the refund one. We have a lot of questions. Okay, this one is the one. Thank you so much, Ali. So in this case, we asked a question out of context. We know that in our application, we are working with tax data, but look at the kind of answer we got without the RAG context about what is the quickest way to get a refund. And you will see that it will talk about something like if I was buying something in retail and I would get a refund. Now, when I work with RAG, and this one failed for some reason because the answer wasn't there, but essentially we can condition the answers based on the content.